Okay, read this question. Ensure all the important information are all inside the diagram. Next, in part A, part 1, I will need to find the bearing of B from D, meaning there must be a north line from D. With the north line, do a clockwise rotation. Okay, so there's a north line at D. If I want to find the bearing of B from D, from the north line, do a clockwise rotation, I will need to find this angle. Alright? As indicated previously, alright, it's very important to find all the angles within the triangle. So, in my ability, I need to find whatever information I can find out about all the different angles, and take note, all north lines are actually parallel to one another. As such, I can make use of tie. And I'm going to indicate into the diagram what are the information I can actually find out in the diagram. First, alright, I have 118 degree. From that north line to the other north line, I can make use of interior angles. So I can find the angle that I've just indicated in orange by subtracting 118 from 180. Now, by using the concept of angles at a point which is 360, I can find the angle inside the triangle, which is angle DCB, which I obtained to be 44 degree. Next, there's also the important use of angle DBC, which I can find within the triangle again, using the concept of angles on a straight line. With two angles found inside the triangle, I can find the last angle in the triangle for angle DBC. You can clearly see that I found all the important angles within the triangle, and with that, I'm able to find my solution for bearing of B from D, which I obtained to be 200 degree, and take note, it must be in 3-digit format. In part 2, I want to find the length of BD. Alright, same thing, I need to choose the triangle which will give me the most number of information. As such, I will use the triangle DBC. Let me draw that out. After I've drawn my triangle, take note, the length of 3.4 km is opposite 54. I will need to find BD, which is actually opposite 44 degree. Two sides and two angles, I can make use of sine rule. Same thing, applying sine rule. With some simple manipulation, you will need to go and find the length of BD corrected to 3SF. And I'll obtain my BD to be 2.92 km. In part 3, I will need to find the length of AD. It's pretty obvious, if I want to find AD, I have to make use of the triangle ADB. Let me draw that out as well. After I draw the diagram out, it's pretty obvious. There are 3 sides and 1 included angle. And the side we want to find out is opposite the included angle. Alright, 3 sides, 1 angle, we can make use of cosine rule. Alright, so we have the unknown side. It must be opposite the known angle. Let me write that down. So it's cosine 126. Before I insert the 2 sides that is adjacent to the known angle. Same thing, plug into your calculator and do your necessary calculation. And we will obtain the length of AD to be 4.92 km, estimated to 3SF. Take note, in part B, I want the shortest distance possible from B to AD. Alright, so the shortest distance must be the perpendicular distance. Like I say, I need the shortest path from B to AD. So to ensure this is the shortest distance, it must be the perpendicular distance. And I'm going to transfer this information in the diagram I drew just now. I will let this shortest distance be the length, unknown length D. At this juncture, I'm going to put a star because it's very important. Alright, if you want to make use of the shortest distance within the triangle, there's an important concept that you can make use of, which is the area of a triangle. There are 2 formulas for And I'm able to find the shortest distance to be 1.25 kilometer corrected to 3SF.